All right, guys, here we go. Lesson 832. We're going to keep moving with circles in this lesson. So the last lesson we learned that as you add sides infinitely to a polygon, eventually you get to a circle. And we were looking at the area and perimeter of a circle yesterday, and we found that the area was pi and the perimeter was, or the circumference is what we call it for a circle, was 2 pi. Okay, so we're going to look at more of where that's coming from today and take a look at some circles. So make sure you guys open your books to 8.3.2, and I want you guys to work through this problem 100. So go ahead and pause this video here, work through problem 100, go ahead and do A through D. Okay, so try and fill out these parts here. If you want to wait to fill out these two, just hold off on just these two right here, but you should be able to fill out the rest of it. Okay, so pause the video here. I'm estimating around 5 to 8 minutes, somewhere in there. Okay, so pause the video. All right, here we go. So let's go over this. So in part A, it asked you to take a look at these two circles and think about what the relationship was. So here's the cool thing about circles is that no matter what size, the shape of the circle is always the same. So this circle is the same shape as this circle. Okay, it's just bigger, right? So we have a word for that in math, and it's called similar. We've been studying that for a while. So the relationship here, they are similar to each other. So, and this is true between any two circles. So no matter what circles you draw, a circle is the same shape. It's just like two squares are always similar to each other because it's a square. They're the same shape. They can just be different sizes. And if we look on this one, the zoom factor here is going to be 3. Because if we look at this radius compared to this radius, that is 3 times as big. So our zoom factor, or as I call it, the scale factor, is 3. Okay. Now the zoom factor of the circumference or the perimeter, so we call it the circumference for a circle. That's the same thing as the perimeter. That's the distance around the outside. So if you remember that lesson from last week, the perimeter ratio is the same as your scale factor. Okay, so it is 3. Okay, and then the scale factor for the area, remember whatever your scale factor is, you have to take that and square it. So that's going to be 3 squared, which is 9. So if I wanted to find the area, let's say I knew the area of the small one, and I wanted to find the area of the big one, I would just take this area times 9 to get the big one. That's what that means. So our scale factor of the area, or the area ratio, as I call it, okay, would be 9. Okay, that brings us to part C. And it's telling you what the area of a circle with radius 1 is. It was 1 pi units squared, which is what we learned yesterday. This is around 3.14. Okay, in yesterday's lesson, we learned that that's what the area of a circle would be with a radius 1. And then the circumference would be 2 pi, which is around 6.28. So now let's take a look at our area of a circle with a radius of 3, if we had that. Well, if we look at our scale factor, we have to take our original, this is for area. We have to take our area ratio, which is 9, and we have to take that times our original area. Well, if I take 9 times 1 pi units, 9 times 1 pi, that's going to give me 9 pi square units. Okay, so there's my area of a circle with a radius of 3. Then it wants us to find the area of a circle with a radius of 10. So in this one, our scale factor, I'm just going to put SF for scale factor. Our scale factor would be 10. And then our area ratio, I'll put AR for area ratio. Sure, as long as you know what that means, you might have to make a little note there. So the area ratio would be our scale factor squared, which is 100. So 10 squared, 10 times 10 is 100. So that means that the area of this circle would be 100 times the area of this original circle. So if we take 100 times pi, that would be, let's just write that 100 times 1 pi that would be 100 pi square units. Okay. That brings us to our formula. If we had a radius of r, our scale factor is r. If we want to take that to our area ratio, we would take r squared. So if now I want to take r squared times 1 pi square units to get the area of this new circle, I would take r squared times 1 pi. And the way we're going to write this is pi r squared. Okay, that right there is the formula for the area of a circle. It's pi times r squared. So basically, if you know your radius, you can just square it and then take it times pi, and that's going to be the area of your circle. So just like we did on this one, I can see my radius here is 3. 3 squared is 9. 9 times pi is, you can just leave it as 9 pi. Okay, we call this leaving it in terms of pi. That's how easy it is to find the area of a circle. All right, next, let's look at circumference. If we do our circumference, the zoom factor for perimeter is the same as whatever your scale factor was. So with a radius of 3, our scale factor was 3. So I just want to take 3 times 2 pi. And 3 times 2 pi is going to give us 6 pi units. And we're going to write units here, not square units, because circumference is talking about the distance around the outside. And if you imagine a string was wrapped around the outside of a circle, and then you straighten it out, that's a distance, right? So it's just units, not square units. It's not the amount of space that's being taken up. Okay, it's the distance. Okay, so there's that one. So we just take 3 times 2 pi. Same thing with this one. If our radius is 10, then our scale factor would be 10. So we want to take 10 times this 2 pi. If we take 10 times 2 pi, that's going to give us 20 pi units. Okay. Now if we took any radius, let's say it was any radius, what do we do to find the perimeter or circumference of that circle? Well, we want to take r, our scale factor, times 2 pi. Okay, so if we take r times 2 pi, the way I want you to write this one is 2 pi r. Okay, these right here are your two formulas that we're going to be using for the rest of the day. Area of a circle is pi r squared. Circumference of a circle is 2 pi r, where r represents your radius. That's how we get our formulas. Okay, so let's go ahead and write that down below here. So A equals pi r squared. Okay, now you can kind of memorize that pretty easily, just pi r squared. And circumference, C for circumference, is 2 pi r. Okay. All right, I want you guys to use these two formulas on this next problem here. Okay, so r is your radius. Go ahead and use that on this next problem, number 101. So read through that in the book and take another 5 minutes here. See how you do. Okay, so pause the video here and go. All right. Okay, hopefully you pause the video. Let's go ahead and go over this. First one, it says area of a circle with a radius of 8 units. Okay, so it gives us the radius of 8 units. All right, so I'm just going to write that down. R equals 8, because that's my radius. I always like to write down whatever we know. And now if we look at our area formula, because that's what we're trying to find, area is pi times r squared. Okay, so to show our work for this, this is going to be pi times 8 squared. And if we do 8 squared, I believe it said in the directions, leave your answer in terms of pi. Maybe it didn't. Unless I tell you different, you can just leave your answer in terms of pi. Okay? Or if it's a problem where you want to get a decimal, obviously get that decimal, but in this case, let's just leave it in terms of pi. So 8 squared is 64, and times pi, we're just going to put pi. And it's units squared, or sorry, square units because it's area. So 64 pi square units. There you go. Next one. It says find the circumference of a circle with a diameter of 7. Okay, so here's the thing about the diameter. Remember, in a circle, your diameter goes all the way across your circle. Okay, so that's diameter. And then your radius just goes halfway. So your radius is always half of the diameter. We've talked about that a little bit in the past. So if our diameter is 7 units, that means the radius is going to be half of that. And half of 7 is going to be 3.5. Okay. So that brings up our next point here, is when we plug that in, we end up taking 2 times our radius anyways. So if we take, let's just go ahead and write it. So 2 times pi, so 2 pi r, 2 pi times r, which is 3.5, you end up getting 7 pi. And what they're trying to show you on this problem is that whatever your diameter is, you can just take that times pi, and that's going to be your circumference. Okay, so another formula that we can write for our circumference is you can write diameter times pi. So d times pi, where d is the diameter. Okay, so that's just another thing you can do with that. All right, next one, part C, it wants us to work backwards here. It says find the diameter of a circle with an area of 121 pi square units. Okay, so I know my area. My area is pi r squared. That gave me 121 pi. So what I like to do is I like to write out a little equation here. So I know pi r squared gave me 121 pi. Well, right off the bat here, you can cancel out pi from both sides, and you're left with r squared equals 121. And now we can solve for our radius by taking the square root. So if we take the square root of both sides here, the square root of 121 is 11. So that's telling me my radius must be 11 to give me an area of 121 pi square units. Okay, so now I know my radius is 11, and to find my diameter, I need to take that times 2, and 11 times 2 is 22. So there's your answer on that one. Last one, area of a circle with a circumference of 20 pi units. Okay, so let's figure out we need to find our radius to find our area, and we have the circumference. Well, my formula for the circumference is 2 pi r. So 2 pi r gave us 20 pi for the circumference of this circle. Well, the pi's cancel out, so those are gone. So 2 times r gave us 20. Well, 2 times what is 20? That's got to be 10. So that means my radius is 10. Now I can plug that into my area formula because we want to know the area. So to show our work, we're going to do pi times 10 squared. And 10 squared is 100, so we get 100 pi square units. Also, we don't write pi 100 because this is like, we almost consider it like a variable. We put our letters after our numbers, okay? So that's how I want you to write it, 100 pi square units. There you go. All right, next problem. I want you guys to read through number 102. I'm not going to read it for you. You guys go ahead and read through it and answer A and B. Ready, go. All right. Okay, here we go. Let's go over these two. So for letter A, so hopefully you read through the problem. Read through that whole problem about giant sequoia trees in California. Pretty awesome stuff there. It told us that the base circumference of, what was it, the largest sequoia tree on Earth, 102.6. Okay. And that's the circumference of the tree. We want to find the width of the tree base. So we want to find that diameter. Okay. So if we know the circumference is 102.6, we can set that equal to our circumference formula. Okay, and actually in this case, I want to just set it equal to diameter times pi, because we're just trying to find our diameter here, so might as well just set it equal to this. So I can say d pi equals 102.6. Okay, now to solve for the diameter, all I have to do here is divide by pi. So if we divide that by pi, type that in your calculators, and there is a pi button on your calculators. This one we are going to get the decimal answer. So we got 102.6, and we're going to divide it by pi. So divided by, and there's a pi button that looks just like this on your calculators. Hit that, hit equals. There's our diameter. So 32.7. We round that up because this is a 5. Okay, so we got 32.7 feet. And then part B was saying, how does that compare to the width, the length and width of your classroom? So I believe our classroom, if you're looking around there, I think it's around 20 to 25, somewhere in there, feet. So think about that tree would be bigger than our entire classroom. That's a massive tree. So so it would for sure be bigger than the classroom. So that is a massive tree. Pretty cool. Okay, all right, moving on. Let's flip it over to the back. All right, so CPM likes to compare circles to pizzas, and that helps us get some vocab words here. So let's take a look at number 103, and I want you guys to, let's just go one at a time here. Start off by answering letter A. So in number 103, it says, to celebrate their victory, the girls' ice hockey team went out for pizza. Okay, I want you guys to read letter A in your teams and work in your teams to figure out these 4 things. Okay, go ahead. All right, so hopefully you paused the video. It took a couple minutes here. It told us the diameter of the pizza was 20 inches. I would automatically change this to the radius. I want to find the radius because that's what our formulas are based on. Area is pi r squared, and circumference is 2 pi r, or d times pi. Okay, so our 2 formulas are based on radius, so I want to know the radius of this to help me find this stuff. So for the diameter, if that's 20, my radius is going to be half that, so 10 inches. All right, so the area of the entire pizza. If we find that area, we're going to take 10 and we're going to plug it in for our area. So pi times 10 squared. And that's going to be 100 pi square inches. You can leave your answer in pi, in terms of pi. Okay, it says leave it in exact form in the book. So that just means don't convert it to decimal form. Okay, and then the length of the crust, they're saying the crust is like that distance around the outside of your pizza, so that's our circumference. So 2 pi times 10, 2 times 10 is 20, so you get 20 pi for that. And then it said the goalie ate half the pizza. So we want to take half of these to find how much the goalie ate. Half of 100 is 50, so we get 50 pi. Half of 20 is 10, so 10 pi was the length of crust that she ate. Okay, so there you go. There's your answers on that one. All right. Okay, go ahead and try out letter B. So go ahead and read through letter B, pause it, and try that one out. Okay, so take maybe 3 minutes. Okay, pause it here, take 3 minutes, answer letter B. All right, here we go. So with this one, it was saying that Sonia had a different slice of pizza that had a diameter of 16 inches. I'm automatically going to write down my radius. The radius would be 8 inches, half of 16. Okay, so if I'm going to draw a picture of Sonia's pizza off to the side here. So we know that the radius is 8. Okay, so we've got that. And it said that she ate a slice that was 45 degrees. Okay, so that's about, something like this. Okay, that means that the central angle of her slice was 45 degrees. Okay, so if we want to find the area of just her slice, we want to find what portion of the entire pizza that was. Well, if you think about a whole pizza, that's a full 360 degrees. So we need to find what fraction that is out of the whole 360. So if we do 45 out of 360, and you can reduce that in your calculators, and your calculators are a little bit fancier than mine. If you do 45 divided by 360, you can convert this to a fraction just by clicking that white button. It's down here. You can click that white button, it'll tell you the fraction. I have to go and do this. Okay, so it's 1/8. Okay, so this 45 out of 360 is 1/8 of the pizza. Okay, so what I want to do is I want to find the area and circumference of the whole pizza and then take 1/8 of that. Okay, so the area of the whole thing is pi times r squared, so pi times 8 squared, which is 64 pi, and that's square inches. That's the whole pizza. And then the circumference, or the crust, is 2 pi times 8, and 2 times 8 is 16, so 16 pi inches. But now I only want 1/8 of that. So you can multiply these by 1/8 or by that decimal, 0.125, okay? Or the same thing as dividing by 8 is 1/8. So if I take 64 pi divided by 8, I get 8 pi. That's the area of the slice that she ate. And then the length of the crust, if I take 1/8 of 16, you can divide by 8 or again multiply by 1/8, and you get 2 pi. And again, remember, these are two different things. This is square inches is area. That's the amount of space that it takes up, two-dimensional space. And this is a distance, so that's the length of her crust. Two different things that we're talking about here. Okay. All right, next, let's take a look at part C. And when you read through part C, guys, it's talking about the Goalies pizza. So our radius is 10 inches if you want to write that down here. Radius is 10 inches for this problem. Okay, go ahead and read through part C. Answer that question. Go ahead. All right, so hopefully you took a couple minutes, paused it, went through these ones. So this one, we have another slice of the Goalies pizza, and our central angle was 72 degrees. And since it was the Goalies pizza, our radius was 10 inches. So if I want to find what fraction of the pizza this was, I have to do 72 out of the full 360. That's what I want to find. So 72 degrees out of 360, that's going to tell me what fraction this is. And if you did 72 out of 360, that reduces to 1/5. Okay, so now when I find the area of the slice, I just want 1/5 of the total area. And when I want to find 1/5 of the circumference to find the length of the crust. Okay, so let's go ahead and do the whole pizza. So area is pi, well actually we already know what it is, don't we? Okay, we have the area and circumference up here. So area of the whole pizza was 100 pi, and the circumference was 20 pi. So area was 100 pi, circumference was 20 pi. Okay, now I only want 1/5 of that because that's the portion that Sonia ate. I think that's who it was, right? Sonia, yeah. So we want 1/5 of this. So if we take 100 pi divided by 5, or we could do 100 pi times 1/5 times this fraction, that gives you 20 pi square inches. Okay. And then the next one, the length of the crust, we want 1/5 of 20 pi because that was the whole crust, and we want 1/5 of that. And if you divide that by 5, you get 4 pi inches. So that's the distance of crust. So that's this length right here, was 4 pi inches. Okay, and the area was 20 pi square inches. All right, got two more problems here. This is where they introduce the vocab words in part D. Okay. All right, so go ahead and read through. On this one, go ahead and do both D and E. So pause the video here, take maybe around 8 minutes here. Do both D and E. So read through those two problems and do D and E. So pause the video here and do those two. All right, so for part D, we learn about what's called an arc. So this is like the pizza crust. That's called an arc. So however you can remember that, it's just like the length of a pizza crust is an arc. And so when it says a circle is radius 6 centimeters, we want to find the arc length. So with a central angle of 30 degrees. So that's our arc. We want to find what fraction that 30 degrees is first. So find the fraction first. So out of 360, let's find what portion of the circle we're dealing with here. And that reduces to 1/12. So this is 1/12 of the total circumference is what we want to find. So now I want 1/12 of the total circumference. So let's find the whole circumference. So if I do circumference is 2 pi times our radius, which is 6, that's going to give me 12 pi. Okay, now to find just the arc length, I just want 1/12 because my angle was 30 degrees. So if I divide that by 12, so let's do that, divide that by 12, or take it times 1/12. That's a 12 there. You get pi. Okay, so if you wanted to write that as a decimal, it's around 3.14 centimeters. And it's a distance. So on tests and quizzes, you need to write the units. Make sure circumference is centimeters, not square centimeters. Okay, now last one, it wants you to find the area of a sector. So the sector is like the pizza slice. It's like the whole slice. So that's a two-dimensional space is a sector, whereas the arc is just a curved line segment. All right, so the area of the sector with a central angle of 20 degrees. First of all, let's find out what fraction that is out of 360. That's around 1/18 of your circle. So I want 1/18 of the total area of the circle would be just the area of that sector. So if I do the whole circle, area would be pi r squared, so pi times 10 squared. That's 100 pi. Okay, now I only want 1/18 of that whole area. So I want to either divide this by 18 or take it times 1/18. And that's going to give us, if you reduce the fraction, it's 50 pi over 9. Or you could write that as it's around 17.5. So if you want to type that in your calculators, you could do 100 pi, and then divide that by 18. So you get around 17.5 as your answer. There you go. Okay, we'll be working more with circles this chapter. So we've got one more lesson on circles tomorrow. And then we're going to do the team test and closure on Thursday. And then we will have the test on Friday. Okay, so email me with any questions, guys. Play this video back. If things happen too quickly, you can always watch this video at home if you're struggling with this. Yeah, just keep working hard, guys. It's just one more week. I should be coming back on Monday, so look forward to that. I'm excited to come back. And yeah, keep working hard, guys. So make sure you're doing your homework, getting those turned in, and it'll be worth it. All right.